Hello students, my name is Shayan Mitra. I am the faculty member of Department of Electronics and Communication Engineering of Greater Kolkata College of Engineering and Management. Today I am going to taking the lecture number 29 of Embedded System, code name EC703B, and today's topic is about the brain machine interface. So brain machine interface is a topic which I am going to discuss today is about the embedded system. Mm, so let's begin with the uh, topic. So let's begin. So the contents are the introduction of brain machine interface in details, the principle of brain machine interface, block diagram description, challenges and future expansion, and the conclusion. These are the contents of today's lecture. So let's go to the next page. The introduction. A brain machine interface is a communication system that does not depend on the brain's normal output pathways of peripheral nerves and muscles. BMI uses brain activity to command, control, actuate, and communicate with the world directly through the brain integration with peripheral devices and systems. It is new communication link between a functioning human brain and the outside world. These are electronic interfaces with the brain, which has the ability to send and receive signals from the brain. The signals from the brain are taken to the computer via the implants for data entry without any direct brain intervention. Basically, what all these things really means is uh, there are different kind of muscle interference which is required to complete our physiological event or task that is required uh, to keep our body alive or as well as an exist. Now now if we have to have a brain machine interface where we will control our functionality, we will control our uh, uh, output control. Suppose used I have a prosthetic hand which has different kind of system. It has been created by a system. Now that specific hand which was connected which is locked on our shoulder, and few wires are connected using different kind of uh, technology, different kind of sensors, and through the sensors it directly connected to our uh, sensory organ which basically controls our activity. Now suppose I have to move my hand, so what will happen, what is the function, how it works basically. uh, Suppose I have to lift my teacup. Okay, so what would I do? I will uh, give a command to my hand that pick the uh, teacup because I want to drink the tea. So it will um, give the signal to my hand, and my hand will pick up the tea teacup. So now few activities. Now what has been written here is that a brain machine interface is a communication system that does not depend on the brain's normal output pathways of peripheral nerves and muscles. So normal output pathways are my hand, my leg, all the physiological activity that I could perform using my brain. So in case of brain machine interface, we don't use all those normal output pathways of peripheral nerves and muscles. What we use, brain activity to command, control, actuates and communicate with the world directly through brain integration with peripheral devices and systems. So I will conduct a operation where my peripheral devices will act according to the command of my brain. So this is the function of a um, brain machine interface. Okay, so it's a new that's why it's a new communication link between the functioning human brain and the outside world. So we have to create a new communication link, because the physiology, to perform all the physiological event, we already have a different kind of link, communication link between our brain and our hand, our eyes, our mouth, our nose. We already have those established communication link, but we have to create a specific new communication link through which we can command a peripheral device which is not basically the part of my body. It has been uh, prosthetically created. Okay, a new thing, a prosthetically created part. Okay, so uh, we have to create another communication link with our brain. So this is nothing but this is what is the definition. This is what is the definition of brain machine interface. Okay, so that has been written here is that is a new communication link between a functioning human brain and the outside world. These are electronic interfaces with the brain, which has the ability to send and receive signals from the brain. The signals from the brain are taken to the computer via the implants for data entry without any direct brain intervention. Okay, so using those implants, we basically capture the motion. We capture the data that has been the that through the motions. Okay, so how it was, what is the efficiency of the brain machine interface. So that's how. So let's go to the next slide. Now, what is BMI? BMI is a brain machine interface, allow for activity in the brain to be sent or received from a computer. It attempts to mesh our minds with machine. Brain machine interface is a communication system which enables the user to control special computer applications by using only his or her thoughts. It allows human brain to accept and control a mechanical device as a part of the body. Purpose: it is to provide a method for the people with damaged sensory and motor functions to use their brain to control the artificial device and restore lost ability via the devices. Okay, so this is the purpose. Okay, so let's go to the next slide. One second. Okay, so main principle behind this interface is the bioelectrical activity of nerves and muscles. Okay, the brain is composed of millions of neurons. These neurons work together in complex logic and produce thought and signals that control our bodies. When the neuron fires or activates, there is a voltage change across the cell, 100 millivolt approx, which can be read through a variety of devices. Okay, so this is the uh, basic main principle of a brain machine interface. Okay, so this is the end of a main principle. Let's go to the next slide. Components of BMI. What are the components of BMI are? Implant device, signal processing section, multi-channel acquisition system, spike detection, signal analysis, external device and feedback system. So how it works, let's analyze how all these components works. So from this part of this brain, all the data acquisition took place. Okay, the first step is to the data acquisition. So all the data will be acquired from the different brain signals, and it goes to the pre-processing enhancements, where the before the processing part the enhancement will take place. Okay, so the signal enhancement will take place before all the signals before the signals are fed to the processor. So Okay, so this is the part. So this is the pre-processing enhancement part. After the completion of this part, so after the pre-processing enhancement part, the features extraction will took place. So this is the data acquisition part where the data has been transferred to pre-processing enhancement. After this process, the features extraction, the signals will extract, and the translation algorithm will provide the specific signal which are fed to four different categories. One is a visualization, one is sonification, audification, another is haptic tactical stimulus, temporal and spatial information, and another one is olfactory simulation. So two kind of simulation will work. One is olfactory simulation where the scent, odors and pheromones will be detected. Another one is haptic tactile stimulus, temporal and spatial information where the tactile, vibration, electrical, TMC, thermal, microtexture, shape, force, all this information will be collected, and all those are also fed to the human body. So through which we will collect all the data which is required to suppose we have created a synthetic of basically prosthetic hand. So if we have to conduct some specific instruction through the hand, so those hand is not automatically attached to my brain. So I will create a brain machine interface through which I will command those prosthetic hand to do some specific job, and brain's command according to my brain's command it will provide us the information. Okay, so this one, so first the preparation enhancement will took place, then the feature extraction will took place, then the translation algorithm. Through the translation algorithm, all these features, all the signals will categorized and will be fed in different processor or digital signal processor or in microcontroller. Those all contain the microcontroller. So all the analog signals will be fed to the signals through 0 1 digital inputs. They are stored in the so visual part. We also have a processor. We also have a sonification audification part. We have haptic tactile stimuli, temporal and spatial information, and olfactory stimulation. So all this, after all these components work together, we come these are the components which basically help to create the brain machine interface which is desired or required. So let's go to the next slide. The electroencephalography. The electroencephalography. What is the function of electroencephalography, which is known as EEG? So electroencephalography is a method used in measuring the electrical activity of the brain. The EEG signal can be picked up with the electrodes either from scalp or directly from the cerebral cortex. The EEG is measured from the surface of the scalp by measuring potential difference between the actual measuring electrodes and the reference electrode. So all those voltage difference will be calculated as a data. All those data will be stored in a specific processor and which will be fed to the system. So the all the algorithm that is required to move a hand, which is natural, the brain, the movement, the command, the electric signals, those are generated by the brain to conduct a specific task through the hand which it already possessed. Now suppose that hand needed to be, because of some incident, needed to be replaced by a specific hand which is a prosthetic hand. But now this prosthetic hand doesn't have that compatibility with the brain, because as it is a not natural hand. So what how do we uh, conduct such operation where we will use a prosthetic hand which has been joined with a with that specific person who doesn't have the hand. So how that specific prosthetic hand works as a real hand. So now the basic function of the real hand was to follow the instruction of brain. The brain will provide the command. So during creating a command to instruct the hand, it creates very specific neural entities, create some signals or pulses or electric voltage. uh, so all those specific voltage or neurons signals, basically electric pulses, needed to be recorded. Now if we can uh, store all those data of electric pulses, then we can use all those datas to create a specific algorithm which can be connected to the brain now, and all those algorithm will be fed to the hand, which does have a processor and algorithm based processor. So as the body commands that signal to the specific signal processor, it obey all those instruction. Okay, so it decode those instruction and obey those instructions. So until unless that specific hardware doesn't possess the specific algorithm, it can't operate according to the instruction of a brain. So that's where the electroencephalography comes into the picture. The electroencephalography is a method used in measuring the electric activity of the brain. So it measures the electric activity of the brain naturally. The EEG signal can be picked up with the electrodes either from scalp or directly from the cerebral cortex. The EEG is measured from the surface of the scalp by measuring potential difference between the actual measuring electrodes and the reference electrodes. Okay, so let's go to the next slide. Implant devices. The EEG recorded with electrodes which are placed on the scalp. Electrodes are small plates which conduct electricity. They provide the electrical contact between the skin and the EEG recording apparatus by transforming the ionic current on the skin to the electric current in the wires. The implants must be monitored closely because there is a potential for almost anything when introducing a foreign signals into the brain. Okay, so the signal processing section, multi-channel acquisition system. At this section, amplification, initial filtering of EEG signal and possible artifact removal takes place. Spike detection. Incorporating spike detection will allow the BMI to transmit only the action potential waveforms and their respective arrival times instead of the sparse raw signal in its entirety. Signal analysis. In this stage, certain features are extracted from the pre-processed and digitized EEG signal. EEG signal. So this is the visual feedback. Okay, this is the signal processing. Now after the signal processing, the signals will be fed to the arm, and arm works accordingly. This is the number of neurons, and this is the detected. Okay, so let's go to the next slide. External device. The classifier's output is the input for the device control. The device control simply transform the classification to a particular action, such as robotic arm. And feedback device. Feedback is needed for learning and for control. The real-time feedback can dramatically improve the performance of a brain-machine interface. Okay. So let's go to the next page. Application. First application is the auditory and visual prosthesis. Okay. Prosthetic limb control, thought control motorized wheelchair, thought control prosthetic arm for amputes, various neuroprosthetic devices that we have already described here. We have already described that how the specific neuroprosthetic device such as robotic arm that could be essential and very useful. Basically, suppose we don't have a hand but we can use a robotic arm. We just have to feed all the algorithms that as neuron signal pulses through using the sensors. We collect all those data, we create a memory base or data, we fed those data when we creating a specific processor to perform those specific tasks. Now after the processor has been created, it process the data that would fed to him, and it will work according to it. So all the specific very basic tasks or specific tasks that a hand could do, it will be fed to the the hardware will create in that way the specific signal that is required to provide the datas of the motor control of a human of a hand will be fed using the by reading all the neuron impulses from the brain, and it will fed to the hardware. Okay, using as a software, it will hit the algorithm of the specific signal algorithm will be fed to the uh, processor of the hands. So now if we connect a hand with the all the specific where wiring will be prompted, and it is fed to the it will connect it to the brain with specific uh, framework. Now as the brain conduct the specific neuron pulses will provide the specific changes in the sensors. Those sensors will provide the specific data or the control signals or the instruction which will be fed to the arm. Now the arm already have all those algorithm already inbuilt in the specific robotic arm, so it will act accordingly. So there will be no problem or obligation for the hands to perform all those tasks. So next page is advantages. In this era where drastic diseases are getting common, it is a boon if we can develop to its full potential. Also, it provides better living, more features, more advancement in technologies, etc. Linking people via cheap implants to super intelligent machines seems to a natural progression, creating in effect of superhumans. Linking up in this way would allow for computer intelligence to be hooked more directly into the brain, allowing immediate access to the internet, enabling phenomenal math capabilities and computer memory. By this, human can get gradual co-evolution with computers. These are the advantages of brain-machine interface. Next point. Challenges. Connecting to the nervous system could lead to a permanent brain damage, resulting in the loss of feelings or movement or continual pain. Any kind of foreign impulses could create havoc uh, to any kind of human brain. Thought control and prediction of future can goes wrong. Virus attacks may occur to brain, causing ill effects. Okay, so the next page, future expansion. The future expansion is a new thought communication device might soon help severely disabled people get their independence by allowing them to steer a wheelchair with their mind. Mind machine interface will be available in the near future, and several methods hold promise for implanting information. Linking people via cheap implants to super intelligent machines seems to a natural progression, creating in effect superhumans. Okay, let's go to the next slide. Conclusion. Cultures may have diverse ethics, but regardless, individual liberties and human life are always valued over and above machines. What happens when humans merge with machines? The question is not what will the computer be like in the future, but instead what will we will be like. What kind of people are we becoming? BMIs will have the ability to give people okay the specific need. Okay, so so we will conclude our lecture here. In the next lecture, what is the RFID and mobile phones, how mobile phone works. Okay, so thank you, bye.